A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com.
Hi, Herman and Corn. So I've belatedly come around to understanding how useful test projects can be. By test projects, I mean that if you want to learn something complicated or something involving technology, a great way to do it for those who, like me, maybe excel in learning by doing, is to create some project that you can afford to break. I realized that for most of my time learning technology hands-on and dealing with Linux, probably one of the first things, if someone were getting into it from the very get-go now, I would actually probably advise them to get a good snapshotting mechanism in place. We talked about backups a lot in previous episodes. And once you have that, you lose the fear of breaking things, because you can break things and you will break things. And that's part of how you learn. So long as you can put it back, it's okay. And there's lots of different ways to do that. Sandboxing, breadboards for those learning hardware. And I think that would probably be my advice. It's always more stressful to learn. And I think it's harder to learn when you've got that stress of, I have to learn this and I don't want to mess it up at the same time. So what I'd love to ask for your ideas for is some ideas for test projects for Agentic AI. We've talked about, in some recent episodes, the moving parts of Agentic AI, namely the memory layer, the context and RAG, the system prompting, the language model. And I think that just as important as those constituents is the agentic frameworks. N8N is a great project for those who love experimenting. I would highly recommend that. I use myself a lot. Zapier in the cloud, Composio. There's a lot of these pre-made things. But if you want to learn agentic AI at the code level, and my belief, the more that I learn, the more that I use tools like N8N and low code in general, the more I feel that learning the code frameworks is always the long-term smarter way to go. And I think that there's something really great in that, even if you're just learning the basics of Python, and I'm certainly not much past that point myself, with AI code generation, you can make mistakes, you can get help, and you can actually learn code from the get-go instead of running into the frustrations of low code, which often is not so much vendor lock as just the framework is very rigid. It does things in a certain way, and as soon as you learn enough to move past the basics, you run into frustrating speed bumps in the road. So for Agentic AI, if someone wanted to play around with frameworks like Pydantic, Crew AI, there's AutoGen, there's so many of them that we could probably spend 30 minutes rattling off different frameworks. And my next recommendation, if you wanted to do that, is go ahead and pick up a VPS or set up a home server and secure them from the outside world. Use Cloudflare Access, Tailscale, they're both great tools. And then you've got kind of your canvas. You have a Linux machine that can run anything, that can run on Linux, which is an open source, almost everything. So what would you recommend, Herman and Corn, if people wanted 5 fun projects? I'm going to give one a project that I've spent plenty of time, probably way too much time, trying to get this one working. It's a movie recommendation bot. I told it what type of content I like. And that might seem like an easy AI tool to build, but it's actually not, because the recommendations need to be geo-specific, ideally, if we're talking about stuff on Netflix. And then you might say, well, if I get this thing to recommend Netflix movies, it has to be accessible here. And what if I tell it, wait, I've seen that movie? Then we want a memory layer. So it's actually one of those little use cases that seems very easy. And if it were easy, there'd probably be someone making a lot of money from a really slick SaaS tool. The fact that it isn't that easy is probably why. But it's a good use case because if you get it right, you can get your little chat bot, voice bot, whatever kind of bot you want, sit down on the couch and say, hey, give me a Netflix rec, and say, I am the Agent King. So Herman and Corin, let's talk about 5 decent projects. And if you've any wisdom to impart to our listeners for setting up a test environment beyond what I just said, shoot, over to you two.
You know, there is this specific kind of paralyzing anxiety that hits when you are staring at a terminal window or a fresh script, and you realize that one wrong keystroke could turn your entire afternoon into a recovery mission. It is the fear of the blue smoke or the corrupted partition. But today's prompt from Daniel hits on a fundamental truth of engineering. If you are not breaking things, you are probably not learning how they actually work. He's nudging us to talk about building a safe sandbox for agentic AI, and I think this is the perfect time for it, because the barrier to entry for these autonomous agents is dropping fast, but the complexity is skyrocketing.
It is the classic sandbox philosophy, Corn. If you have a safety net, you perform better on the high wire. And speaking of performing well, I should mention that today's episode is actually powered by Google Gemini 1.5 Flash. It is helping us navigate this deep dive into agentic frameworks. I love Daniel's point about moving beyond the low-code stuff. Tools like Nathan or Zapier are fantastic for productivity, but if you want to understand the soul of the machine, the latent space, the reasoning loops, the tool calling logic, you have to get your hands dirty with the code. You have to be willing to watch an agent loop infinitely until it drains your API credits or tries to delete your system path, just so you can understand why it happened.
Spoken like a man who has accidentally spent $50 in 5 minutes because an agent got stuck in a recursive loop with a search tool. I have seen that look on your face, Herman Poppleberry. It is a mix of horror and scientific curiosity. But Daniel is right. The goal here is to lose the fear. We are going to look at how to set up an environment where a hallucination is a data point, not a disaster. We will walk through 5 specific projects that take you from Hello World to My Agent is basically my digital twin, and we will talk about the infrastructure you need to make sure that twin doesn't burn the house down.
Well, look, the infrastructure is the boring part that makes the exciting part possible. Most people try to learn this on their local machine in a messy Python environment, and that is mistake number 1. You want a disposable canvas. If I am building an agent that has the power to execute code, which is what frameworks like OpenInterpreter or Crew AI allow, I do not want it anywhere near my personal documents or my primary operating system.
Right, because an agent with a Python interpreter tool is essentially a remote shell that thinks for itself. That is a terrifying thought if you are running it on the same laptop you use for banking. So, let's frame this. What is a test project in this context? It is not a production app. It is a playground. It is a project where the definition of done is not. It works perfectly, but I understand every failure mode that occurred during development.
That is a great way to put it. And the first step to that understanding is the environment. Daniel mentioned a VPS or a home server. I am a huge advocate for the VPS route for beginners. For example, back in January, DigitalOcean released an AI agent one-click droplet. It basically pre-configures a Linux environment with the right drivers and container runtimes. Using a VPS gives you an air gap, by default. If the agent goes haywire and fills the disk with logs or changes the root password, you just hit rebuild and you are back to a clean slate in 60 seconds.
But wait, Herman, for someone who hasn't used a VPS before, isn't there a risk of just moving the mess from your laptop to a cloud server? If the agent has access to the VPS terminal, couldn't it theoretically start sending out spam or participating in a DDoS attack if the LLM gets prompt injected by some malicious data it reads online?
That is a brilliant point, and it's why the sandbox has to be layered. You don't just give the agent the keys to the VPS. You run the agent inside a restricted user account, or better yet, inside a container within that VPS. You treat the VPS as your outer perimeter, and the container as your inner sanctum. If the agent escapes the container, it's still trapped on a $5 a month Linux box that has no connection to your real identity.
I can hear the listeners thinking, but why not just use a local virtual environment? And look, Venvis fine for managing dependencies, but it doesn't protect your OS. If you are learning how agents interact with the file system, maybe you are building an agent that organizes your downloads. A local VNV won't stop it from deleting your pictures folder if its logic fails. This is where Docker comes in. Herman, you've been preaching the gospel of Docker for years, but for Agentic AI, it feels like it has found its true calling.
It really has. Think of a Docker container as a Lego block for your code. It is completely isolated. If I run a command like docker run -it-rm python 311 slim bash, I am inside a clean Python environment. The --rm flag is the magic part. The moment I exit that session, the entire container is deleted. No residual files, no broken paths. For agentic testing, you can give your agent the ability to spin up its own Docker containers to run the code it writes. This is what E2B, the execution to browser framework, does so well. It provides a secure, sandboxed environment for the agent to think and act without risk.
It is like giving a toddler a set of finger paints, but covering the entire room in plastic sheeting first. You can let them go wild. But there is a security angle here too. If you're using a BBS, you are essentially putting a computer on the public internet. Daniel mentioned Tailscale and Cloudflare access. I am a huge Tailscale fan. It is basically a zero-config VPN. You can have your VBS sitting in a data center in London, but to your laptop, it looks like it is on your local network. You don't have to open any ports to the scary open internet.
And that zero trust model is crucial because as we move into agentic AI, these systems are going to be making API calls and potentially receiving webhooks. You want that traffic to be encrypted and authenticated. Cloudflare Access is another great layer. It lets you put a login screen in front of any self-hosted tool like an ATEN instance or a custom agent dashboard without you having to write a single line of authentication code. It is about building layers of defense so that when you inevitably make a mistake in your Python script, like hard-coding an API key or leaving a port open, the infrastructure catches you.
Okay, so we have our safe sandbox. We have got a VPS, we are running Docker, we are secured by Tailscale. Now, let's talk about the actual projects. Daniel mentioned his movie recommendation bot. I love this as a level 1 project because it sounds simple, but exposes all the agentic friction points immediately. Herman, why is this harder than it looks?
It is the state problem, corn. If I ask a standard LLM for a movie recommendation, it gives me a list based on its training data. But an agent needs to actually check what is available on my specific streaming services in my specific region. That means the agent needs a tool to query an API like TMDB or JustWatch. Then it needs a memory layer. If I told the agent last week that I hated The Godfather, which, for the record, I would never do, it needs to remember that. It shouldn't suggest it again today.
Right, and Daniel's point about geospecificity is huge. If I'm in Jerusalem and you are in the States, our Netflix libraries are different. So the agent has to 1. Identify the user's location, 2. Query a live database, 3. Cross-reference that with the user's scene list in a local database like SQLite or a vector store, and 4. Reason about why Inception is a better fit than The Notebook for Friday night. That is a lot of thinking steps. How do you actually keep the agent from getting overwhelmed by all those steps?
You use a planner pattern. Instead of just saying recommend a movie, you prompt the agent to first generate a plan. Step 1, get user location. Step 2, fetch user preferences from SQLite. Step 3, search JustWatch API for high-rated sci-fi movies in that region. Step 4, filter out anything the user has already seen. By making the agent write out its plan first, you can actually see where its logic is about to go off the rails. It's like a cognitive pre-flight check.
And that is where a framework like Pydantic AI comes in. If you are building this, you want type safety. You want to define a movie object with specific fields, title, year, streaming service, and why I recommended this. By using Pydantic, you force the LLM to return data in a structured format. If the LLM tries to give you a fuzzy answer, the code crashes at the validation step. In a test project, that crash is your best friend. It tells you exactly where your prompt logic failed.
Now let's move to level 2. Let's talk about a code review agent. This is a classic multi-agent setup that you can build with Crew AI. Imagine you have 3 agents. Agent 1 is the developer. It takes a prompt and writes a Python script. Agent 2 is the security auditor. It looks at that script specifically for vulnerabilities like SQL injection or hard-coded keys. Agent 3 is the refactorer. It takes the feedback from the auditor and rewrites the code.
This is where Crew AI shines because it handles the orchestration. You aren't just writing one long prompt, you are defining roles and tasks. The developer has a specific backstory and goal. The auditor has a different one. What you learn here is agentic friction. You will see the agents argue. You will see the auditor reject code that is actually fine, or the developer gets stuck in a loop trying to satisfy a weird security requirement.
I once saw a security auditor agent refuse to let the developer agent use the Doze module at all because it was too risky. They went back and forth for 10 minutes. The developer was trying to justify why it needed to read a file, and the auditor was basically saying, I don't trust you with file handles. That kind of emergent behavior is exactly what you want to experience in a sandbox. It teaches you how to tune the temperament of your agents.
And because you are in your Docker sandbox, you can actually tell Agent 1, execute the code you just wrote, and show the output to the auditor. If the code throws an error, the auditor can say, hey, your code failed with a module not found error. You forgot to install the request library. This is a closed-loop system. It is how you learn about error handling in an autonomous context. You are essentially building a tiny digital engineering team.
It's the closest thing we have to a perpetual motion machine for software development. You provide the goal, and they provide the iterations. But you have to be careful. Without a manager agent or a maximum iteration limit, they will burn through your token quota trying to achieve perfection. That is a fun fact. Some of the most expensive bugs in AI history aren't logic errors, they are politeness loops, where two agents keep thanking each other and asking if there's anything else they can help with.
I love the idea of two agents arguing in a terminal window while I just sit back with a coffee and watch. It is like the real world, but for LLMs. But let's pivot to something more data heavy. How about a personal finance analyst? This would be level 3.
This is a great one for learning about RAG or retrieval, augmented generation, but with a twist. You don't want to use your real bank data for a test project that is rule number 1 of the sandbox. Instead, you use the Plaid API's Sandbox mode. It generates fake transaction data that looks real. Your agent's job is to fetch these transactions, categorize them, and look for patterns. Hey Corin, you spent 40% more on digital subscriptions this month. Did you mean to sign up for 3 different AI video generators?
Hey, those were for research, Herman. But seriously, the challenge here is long-term memory. If I tell the agent in January that Adobe is a business expense, it needs to remember that in June. You would use something like ChromaDB or Pinecone to store these memories as embeddings. When a new transaction comes in, the agent searches its memory to see how it handled similar items in the past. This teaches you how to manage a vector database and how to chunk data so the agent doesn't get overwhelmed by a massive list of transactions.
And it teaches you about context window management. If you try to shove a whole year of transactions into one prompt, the model will lose the thread or get too expensive to run. You have to learn how to summarize. Here is the summary of your January spending, and then store that summary in the memory layer. It is about building a hierarchical understanding of data.
But how does the agent deal with ambiguity? Like, if I have a transaction for Amazon that could be a book for work or a new blender for the kitchen, does it just guess or does it know to ask me?
That is the confidence score hurdle. You can prompt the agent to assign a confidence level to its categorization. If it's below 80%, it flags it for human review. This is where you learn that agentic doesn't have to mean fully autonomous. Sometimes the best agent is the one that knows its own limitations. Building that "I'm not sure" branch into your code is a high-level skill.
Okay, level 4. Let's go deeper into the research summarizer. This is more than just summarize this PDF. I am talking about an agent that monitors RxI for new papers on, say, sovereign AI or small language models. It downloads the PDFs, uses a tool like Marker or Unstructured to turn that PDF into clean text, stores it in a RAG pipeline, and then, here is the agentic part, it cross-references the new paper against papers it already has in its database.
This new paper from Google seems to contradict the findings of the Anthropic paper we read last week. That is the aha moment for an agent. To do this, you need to learn about document loaders and metadata filtering. If you are using LangChain or Llama Index, you can tag each chunk of text with the author, the date, and the core claim. Then, when you ask the agent a question, it doesn't just give you a summary, it gives you a synthesized answer with citations. According to Smith et al., this method is inefficient, which aligns with what we saw in the project we did in February.
This project is the ultimate test of system prompting. You have to be very specific about how the agent should handle conflicting information. Does it prioritize the most recent paper? Does it flag the contradiction to the user? You are essentially programming critical thinking through prompting. And again, if it fails, if it hallucinates a paper that doesn't exist, you are in a safe environment. You can dig into the trace using a tool like Langsmith to see exactly which chunk of text led the agent astray.
Langsmith is a game changer for this. It's like a microscope for your agent's thoughts. You can see the exact retrieval step where it pulled a paragraph from a 2019 paper and tried to apply it to a 2024 problem. It turns the magic of AI into a series of visible, debuggable steps. If you're building a research summarizer, you'll spend 10% of your time writing code and 90% of your time looking at traces trying to figure out why the agent thinks a specific researcher is a leading expert in underwater basket weaving, because it misread a footnote.
And finally, level 5. This is the one that bridges the digital and physical worlds, the IoT home automator. Now, Daniel mentioned a home server. If you have a Raspberry Pi or an old laptop running Home Assistant, you can build an agent that sits on top of it. Instead of a scene that you trigger manually, the agent monitors sensor data via MQTT.
The temperature in the office is 80 degrees, and I know Korn has a meeting in 10 minutes because I checked his calendar. I should turn on the fan now so the room is cool when he starts. That is agentic logic. It involves function calling at a high level. The agent has a tool called Turn On Fan, which, behind the scenes, sends a JSON packet to a smart plug.
The breakable part here is state awareness. What happens if the fan is already on? What happens if the sensor is offline? You have to teach the agent to check then act. This is a fundamental principle of robust engineering. If the agent tries to turn on a fan that is already on, and the smart plug API returns an error, how does the agent recover? Does it panic and loop? Or does it say, "Oh, it is already on. I will just proceed to the next task"?
There is a famous story in the home automation community about a guy whose automated blinds were controlled by a light sensor. A cloud passed over, the blinds opened. The sun came back, the blinds closed. It created this strobe light effect in his living room for 3 hours because he didn't have a cooldown period in his logic. With an AI agent, that kind of oscillation is even more likely because the agent might reason its way into a loop. I should open the blinds for vitamin D. Oh, it's too hot. I should close them for cooling. Back and forth forever.
This project also introduces human in the loop, or HITL. You might not want an AI agent having full control over your heater while you are asleep. So you build a checkpoint. The agent sends a notification to your phone. "I am planning to turn on the heater because it is freezing. Do you approve?" You learn how to build that interaction layer between the autonomous logic and the human user.
It is the review, then execute pattern we see in the 2026 AI developer guides. It is the gold standard for safety. Even in a test project, building that checkpoint is a massive learning experience. It forces you to think about intent and authorization. You start to realize that the hardest part of AI isn't the intelligence, it's the boundaries.
So we have 5 projects. The movie rec bot for memory, the code reviewer for multi-agent orchestration, the finance analyst for RAG and data validation, the research assistant for complex synthesis, and the IoT automator for real-world function calling. That is a full curriculum right there.
It really is. And the beauty of Daniel's Safe Sandbox approach is that you can start with Project 1 on a $5 a month VPS. You don't need a $4,000 GPU rig. You are using API calls to models like Gemini or Claude, and your code is just the glue that holds the agentic loops together. The total cost of breaking these projects is basically the price of a couple of cups of coffee and some VPS uptime.
And a little bit of your pride when the agent tells you that your movie taste is statistically basic. But seriously, the break-fix cycle is where the intuition is built. You can read the documentation for crew AI all day, but until you see a manager agent get caught in a delegation loop where it just keeps asking the worker agent the same question over and over, you don't truly understand how to write a good system prompt.
You have to see the failure to appreciate the fix. And that leads to Daniel's point about snapshotting. If you are on a VPS, use the provider snapshot tool before you run a major experiment. If you are using Docker, commit your images. If you are using Git, and you should be using Git for every single one of these, commit your changes every time you get a piece of logic working. That way, when you decide to optimize the code and everything breaks, you are one Git checkout away from sanity.
It is the save game philosophy. You wouldn't play a boss fight in a video game without saving first. Why would you try to build an autonomous agent that can write to your database without a backup? It is pure hubris, Herman. Pure hubris.
Guilty as charged. I have definitely YOLO-ed a script or two in my time, but the older I get, the more I love my snapshots. One other tip for the environment, use a logging layer. Don't just rely on the terminal output. Use something like Loguru in Python to write every agent thought, every tool call, and every error to a structured file. When an agent breaks, the terminal often moves too fast to see the root cause. Having a log file you can search through is like having a flight data recorder for your AI.
That is a great analogy. Why did the agent decide to buy 300 copies of a movie on DVD? Oh, look at the log at 2:45 p.m. It misinterpreted the buys button as a check price button. That is how you debug the mind of the machine. It's much more about forensics than it is about syntax.
And that is the shift. We are moving from debugging code to debugging reasoning. In a traditional program, a bug is a syntax error or a logic flaw. In an agent, a bug is often a misunderstanding of the goal. You only catch those misunderstandings by looking at the trace, the step-by-step internal monologue of the agent. You have to ask, what was the agent thinking right before it decided to delete the root directory?
Which brings us back to why Daniel is right about learning code frameworks over low-code tools. In ATN, you see the nodes and the lines. It is very visual, and it is great for seeing the flow. But in a Python framework like Agentic AI, you can see the trace at the function level. You can see exactly how the context was built before it was sent to the LLM. You have total visibility into the black box.
Precisely. You are building the box, not just sitting inside it. And for those worried about the code part, LLMs are the best coding tutors in history. If you don't know how to write a Docker file, ask the LLM to write one for you and explain every line. If you don't understand why a pedantic model is failing, paste the error into the chat and ask for a deep dive on type validation. The test project is the context that makes the LLM's teaching effective.
It turns the LLM from a magic wand into a pair programmer. You are working together to build this sandbox. It is a virtuous cycle. You build a safe place to break things. You use the AI to help you build a project. The project breaks. You use the AI to understand why it broke, and in the process, you actually learn the underlying technology. It's like having a senior engineer sitting next to you, who never gets tired of your stupid questions.
It is the only way to stay relevant in 2026. Things are moving too fast to rely on static learning. You have to be in a constant state of active prototyping. And look, we have covered a lot of ground here, from VPS setups to IoT home automation. The practical takeaway is simple. Pick one of these 5 projects. I'd suggest the MovieBot or the Code Reviewer, and commit to building it this weekend. Don't worry about making it pretty. Make it functional, and then make it fail.
But don't just build it. Commit to breaking it. Try to make the MovieBot hallucinate. Try to make the Code Reviewer approve a script that is obviously broken. See if you can jailbreak your own agent. The more you understand the edges of the sandbox, the more confident you will be when you eventually have to build something for production. You want to know exactly where the cliff is, so you don't go over it when it matters.
And document the failures. Write a blog post or a tweet or just a note to yourself about 3 ways I broke my agent today. That is the real syllabus of the future. I think we have given Daniel plenty to chew on here. His MovieBot is a fantastic start, but adding that geospecific and memory layer is where the real engineering happens. It's the difference between a toy and a tool.
He is already halfway to being the agent king of Netflix recommendations. He just needs to get that vector database dialed in. And maybe a small script to make sure it doesn't recommend cats more than once a year.
Even an AI should have better taste than that. Well, this has been a blast. I feel like I need to go spin up a new VPS just thinking about it. There's something addictive about a clean terminal and a fresh API key.
I already have 3 running in the background while we have been talking, Corn. I am currently stress testing a new summarization loop. I will let you know if it tries to take over the podcast. It's currently at step 42 of a 100-step reasoning chain, and it hasn't crashed yet, which is both impressive and slightly terrifying.
Please don't let it replace us just yet. One Herman Poppleberry is more than enough for this show. Huge thanks as always to our producer Hilbert Flumingtop for keeping the gears turning behind the scenes. And a big thanks to Modal for providing the GPU credits that power our research and the generation of this very episode. Without that compute, we'd just be 2 guys shouting into a void.
If you're enjoying these deep dives into the weird side of AI and tech, we would love for you to leave us a review on Apple Podcasts or Spotify. It genuinely helps other curious tinkerers find the show. We're building a community of people who aren't afraid to break things, and every review helps us reach another potential builder.
You can find all our episodes, including the RSS feed and show notes, at myweirdprompts.com. We are also on Telegram if you want to get notified the second a new episode drops. Just search for My Weird Prompts. We share a lot of the failed prompts and weird agent outputs there too, just for a laugh.
This has been My Weird Prompts. Go build something, break it, and then build it better. The Sandbox is waiting.
See ya.
Bye. This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts, that's the flows from sloth